Alright, so the first thing I'm going to do with you guys is I'm going to go through a couple of homework problems because I know usually I have several people ask me some questions about some of the particular ones on the homework. So what you had on your homework was 255, the 59, and 61. I told you to take a look at those again. 28 through 31, 37, 38, 41, and 42, and then page 262 here. I also gave you the option of looking at some of this quiz practice problems because I told you it would look like your quiz that you were taking today. So we're going to take a look at going through a couple of those problems. If you look at 59 and 61, the problems that were on page 255 there, the two word problems, they look kind of scary, but all you really had to do was plug the numbers into your calculator. For instance, in number 59, you have the chemistry example. It says the pH value for a substance measures how acidic or alkaline the substance is. It's given by this formula, and it gives you the pH is equal to negative times the logarithm of however many hydrogen ions you have in the substance, where H plus is the hydrogen ion concentration, moles per liter, if you are in those chemistry classes. So it says lemon juice has a hydrogen ion concentration of 10 to the negative 2.3 moles per liter. What is the pH value? So what you're supposed to do is take out your calculator and do negative logarithm of 10 to the negative 2.3 power right here. You might could even do this one without your calculator if you paid attention in class. This one is the logarithm base 10. So what this is saying is 10 to what power is 10 to the negative 2.3 power? It would have to be negative 2.3. And you would get a positive, because of the negative out in front, a positive pH balance of 2.3. So you're looking at there a acid. So if you did it in your calculator though, you would take negative, hit that logarithm key, and then you would type in that 10 raised to the negative 2.3 power, and you would close your parentheses for your logarithm and get 2.3. Like I said, if you paid attention in class, you should be all right. It's just hitting the calculator buttons on that guide, because that is the logarithm base 10, and the other one on the calculator later is the logarithm base e, this natural logarithm that we talked about in class. Okay, so the next section on the homework had to deal with the inverses that we were talking about in class. And a lot of people want to try to overthink these a little bit, especially that 28 through 31 on your homework. When you look at those, if you see something like 8 raised to the log base 8 of 6x minus 7, everybody looks at this and gets really, really scared because that looks just ridiculously ugly. But 8 raised to the log base 8, these are inverses of each other. So basically they undo each other and cancel out. The answer to this problem is just 6x minus 7. So when you look at those in your homework, basically they should have just canceled out and gave you whatever was in the logarithm or whatever was in the exponent. So on your homework, if you saw one like this, log base 7 raised as an exponent on the 7 raised to log base 7 of x, you would get this equal to x. If you saw this one, log base 5 of 5 to the x power, you get x. So they cancel each other out when you have a logarithm and an exponential function. Because logarithmic functions and exponential functions are inverses of each other, on 37 and 38, 41 and 42, what I actually had you doing was finding the inverse. So I had you looking at something like y equals the log base 8 of x, and I told you to find the inverse. So if you're finding the inverse of this, you switch the x and y. Remember, we talked about when you find the inverse, you switch the x and y. And then you got to solve for y. Everybody panics here because I haven't taught you how to solve for y, right? No, yes I did. What I told you how to do is how to remember the definition of a logarithm. This base raised to this exponent equals this. So 8, this base, raised to this exponent, x, equals this y. You just solve for y. And notice it is an exponential function that is the inverse of a logarithmic function. So when you find the inverse of a logarithm, you should always end up with exponential. If you find the inverse of an exponential function, you should always end up with a logarithm. So if you looked at one like number 41, and you saw e to the x plus 2 power, and you had to find the inverse of this, the first thing you would do is switch your x and y. So you get x equals e to the y plus 2 power. And you would switch your x and your y, and then you would solve for y. Well, that looks really scary, but again, I told you how to take this and rewrite it using your logarithmic definition. This base raised to this power equals this number. So this is going to be a logarithm base e, which, remember, you can write as ln of x equals y plus 2. I don't get it, Mr. Harrison, I don't get it. Look again. This base, which is e, raised to this power, y plus 2, equals x. E to the y plus 2 equals x. So all I'm doing is that thing that we did on that very first day, is I'm just rewriting it from exponential form into logarithmic form. So when you look at this, this is now, when I subtract the 2 over, equal to y, that's my inverse of this one. So notice the inverse of an exponential function is a logarithmic function. Okay, so I'm going to go through with you a couple of problems off the homework, some more on the properties of logarithms that we did last time in class to give you guys a little bit of help with some of those. Taking a look probably at some of the most missed questions on this homework, most people have a little bit of problem with number 8 off of page 262 because people look at it and can't tell what the book's telling me to do. What the book's telling you to do is use one of the properties and use what they give you to find an answer instead of using your calculator. So they're telling you 0.602 is what log of 4 is, and then log of 12 is 1.079. So they give you these two values in the problem, and then they tell you to use that to find the value of the log of 48. Yeah, you're still probably going to have to use the calculator a little bit, so I lied a little bit ago. But you're not going to just type this into the calculator as log 48. And so what they're expecting you to do is to take this and say, okay, log 48 can be split up because 48 is 4 times 12. And using those properties of logarithms we talked about, the log of 4 plus the log of 12 is going to give me the same answer as the 4 times 12 in one logarithm. This is called expanding the logarithm. And so you can take this 0.602 is what this is, and this right here, 1.079, and add those two together. And some of you might be able to get this without a calculator, some of you might not be able to, but you're going to get 1.681 when you add those two together. And what it does is it gives you the ability to break it down into two parts that you do know using those expanding logarithms that we've talked about. Next one would be ones like we had where we were expanding just using those properties. Number 21 is one that some people have trouble with, log base 4 of x over 3y. On this guy right here, you are going to take the log base 4 of x minus the log base 4 of 3y, because this is division. Then you are going to split up this one into 2 because it's going to be the log base 4 of 3 plus the log base 4 of y. Put those in parentheses because they're together on the bottom of the fraction. 23, log base 7 of 5x cubed yz squared. This one has a lot of stuff multiplied across here. So I'm going to split all of that up at one time. Log base 7 of 5 plus the log base 7 of x cubed plus the log base 7 of y plus the log base 7 of z squared. So I'm splitting all of that multiplication up with addition in between each one. So if it's multiplication in here, it splits up as addition. If it's division, it splits up as subtraction. One other thing you can do is if it has an exponent like this 3 and this 2 on the x and on the z, you can also take that number and put it in front of the logarithm. 3 times the log base 7 of x and 2 times the log base 7 of z. Sorry about that. So that would be completely expanded. 25. If you look at 25, this one's kind of ugly. You got the natural log of x squared, y to the 1/3 power. So you can split that up first of all with natural log of x squared plus the natural log of y to the 1/3. Then because this is an exponent, you can move it to the front, so it'll be 2 times the natural log of x. And you can move this one to the front, so it'll be 1/3 times the natural log of y. And there's your expansion. The next section that people have trouble with is the condensing. The condensing are the ones where you have it in multiple logarithms and you try to condense it down to one logarithm. This only works if they're the same base, so you got to make sure that the bases are the same. But when you condense them, make sure also that you are condensing down to one logarithm and not trying to condense it and make it look like two logarithms. So when you squish this guy down right here, you're going to take, first of all, the 5 back into the exponent, the 4 back into the exponent, and I'm sorry, this is number 37 on your homework. You have log of x to the 5th minus log of y to the 4th. Then, because this is minus right here, when you condense it to one logarithm, you have x to the 5th over y to the 4th, because when you have subtraction, it means it was division inside here. Notice that my answer for this one looks like the way the expanding one started. When you take your quiz today, that's going to be the case. When you have your answers for these that are expanding, they will look like the way the ones that are condensing start. So make sure you're paying attention to that when you go through and you start your problems. You'll be able to tell what your answer should look like when you get to the end. So that was 37. Another one that gives people a little bit of trouble is one like number 38. Number 38, when you take this guy, you'll have 5 times the log base 4 of 2 plus 7 times the log base 4 of x plus 4 times the log base 4 of y. Got a lot of exponents in here, so you move the 5 into the exponent, move the 7 into the exponent, move the 4 into the exponent. So this would be log base 4 of 2 to the 5th power. 2 to the 5th power is 32. I'm just doing that in my calculator or in my head if I can do it in my head. Then I move this in here. This will be log base 4 of x to the 7th power and log base 4 of y to the 4th power. Notice there's addition between all of these. So very much like that one that we expanded a little while ago, that we had a lot of things that were multiplying, we separated them with addition. Same thing here, except we're going backwards now. We're condensing. All of these things are adding together. So we will condense them to one logarithm by multiplying 32 x to the 7th, y to the 4th. All of that now is inside that one logarithm multiplied together. The last section, 45 through 48, just deals mainly with things that are approximating values for a logarithm. You will have a little section on this quiz that will involve that, and next class when we start doing some of these problems where we're solving equations with these, you'll have to know how to do this little formula. Basically, it's a little formula, change of base formula is what they call it, to help you find a solution for something like this, like number 45, where it says log base 4 of 7. And so the answer to this is going to be 4 to what power is 7? Well, 4 to the first power is 4. 4 to the second power is 16. So I know it's got to be between 1 and 2, but in order to find the exact answer for this, I use my change of base formula, which says I take the logarithm of 7 divided by the logarithm of 4. Don't get this switched around. The base number is on the bottom. The number that's inside the logarithm is on the top. So you take out your handy-dandy calculator then. You do log of 7 divided by a log of 4. You can also use that natural log if you want to. Most of us use the log base 10 though, because the log base e is just not something we're used to using a lot. So when you press enter, it tells you 1.40, and I'm going to round that to 4. 1.404. So basically it's saying this base 4 raised to this power equals this number. You can always check your answer. If you take 4 and raise it to the 1.404 power, it should give you pretty close to 7. It won't be perfect because you did round your answer a little bit. It won't be perfect, but it'll be pretty close to right on 7. And so that's what you're looking for. When you find a logarithm, it's giving you the answer for a missing exponent. All right, so the last thing I'm going to do with you now is I'm going to take a look at some review for the quiz, kind of give you an overview of what you're about to see on the quiz when you take it. And basically, the idea is it's pretty much everything that we've done in this chapter here, with just a slight few exceptions. We won't have every single type of problem that we've done, but a good majority of the types of problems that we have done in this chapter. So, some of the things that you can be looking for, first of all, is that exponential growth and decay. Remember, we have the exponential growth, that beginning amount times 1 plus the rate raised to the exponent x, or you can have t right here. That's okay. Then you have the exponential decay, the beginning amount times 1 minus the r, 1 minus the rate raised to the x power, or the t right there is okay. Either one of those, you have that same exact function, basically just 1 minus r and 1 plus r. Typically, we did a lot with time because when we were looking at these, we were talking about bank accounts and we were talking about values of cars. And you guys did pretty well on this other quiz that we just took, a little small quiz with this. So I'm not going to spend a ton of time going over this point here. There may be a couple questions, though, where I give you a function that looks something like this. Let's say 3 times 1.07 to the x power. And I just simply ask you, is that growth or decay? And what is it growing by? And so if it is, so you look at this guy, since it's 1.07, I know 1 plus the rate is how I would get 1.07. It couldn't be 1 minus the rate because that would have to be smaller than 1. So, since it's 1 plus the rate, that means this one is growth. And if it is growth, how much is it growing by? Well, if it's 1 plus the rate, that gives me this guy right here, then that means it would have to be 0.07 as my rate. So that means 7% is what this is actually growing at. So included with growth and decay, you're going to have some things that are a little bit non-standard. When you're talking about non-standard, I'm saying things that don't just grow by a percentage every year or a percentage decrease by a percentage every year, but things that may have a certain percentage that they decrease every so often, not once a year, more than once a year, or it takes several years for something to happen. In other words, I'm talking about problems like this. This word that we talked about called half-life. Half-life, remember, is how long it takes for something to decay by a half. So remember with those, you're always going to have your beginning amount. In your parentheses, you're always going to have 0.5, and you're always going to raise it to the time divided by whatever the half-life actually is. I gave you the example of carbon-14 in class, where carbon-14 has a half-life of 5,730 years. So whatever you plug into here for your time has to be divided by 5,730 if you were doing carbon-14. So notice, still decay, still 0.5%, still got your beginning amount, still got your time, but you have to divide your time by your half-life. That's the only difference. Other things that we looked at were problems like this, where we have a certain number of times per year that something is added when we talk about interest. When you look at something like that, I gave you this formula. Remember, it's still the beginning amount. You still have the rate. You still have the time. The only difference is right here on this one, where you see this little n number right here, that is where you would plug in the number of times per year that you plug in interest into your account, or the bank adds interest to your account. So you would be talking about, if it was monthly, you would put a 12 right here. If it was daily, you would put a 365 right here in those two spots. So basically kind of the same idea as half-life. You've got something else happening with the t, and also on this one something else happening with the rate, because they're splitting that percentage up over the year, but they're also giving you that percentage more times a year. The last one that we had was a kind of a special case also, was if things are compounded at a continuous rate. And continuously compounded interest is always going to be the Pert formula. Remember, the Pert formula stands for the beginning amount times e, that natural base e number that we talked about, raised to the RT power. Guys, that means you literally take your beginning amount, if it was $1,000, you multiply it by e, raised in parentheses to the, let's say 2%, 0.02, multiplied by how many years. If you had 2 years, you'd multiply by 2 years. So you just take out your calculator and you do 1,000 multiplied by e, so you hit second and hit that little LN button, 0.02 times 2. Don't make this difficult. You are just taking that base e. That's what makes it continuously add interest. And you get 1,040 and 81. The other section that you'll have on here is an evaluating logarithms section. And we did this last time in class, but when we go through and we look at evaluating logarithms, this is basically, again, just using that definition of a logarithm to help me out. So when you see something like log base 6 of 1, what it's saying is 6 to what power is 1? 6 to the 0 power is 1. So that's what I would be expecting you to put as your answer. If you add something like the log base 9 of 81, 9 to what power is 81? 9 to the second power is 81. So that's what I would be expecting you to answer. So you're still using this base raised to this exponent equals this number. That's the key to understanding logarithms, and that's the key to finding answers. So there'll be a section like this. Some of them will be a little bit easier than others. Some of them will be a little bit harder than others, depending on if there's variables involved and if you're paying attention to what it's raised to and things like that. Some of these will be really quick. Some of these will be just a little bit more thinking involved. So when you look at these, make sure you're paying attention to this base raised to this exponent equals this number. Also on this quiz will be some of the things that I did earlier in class off the homework, those properties of exponents that we talked about, the evaluating logarithms with uglier bases and things that you can't do kind of in your head, the ones that you have to use the calculator for. So if you go back over here, we talked about some of those, like this one, the log base 4 of 7 is 4 to what power is 7. You got to use the calculator to do that. There's going to be about 4 of those on the quiz. Then you have some of these where you're condensing the logarithms, and some of these where you're taking these logarithms and you're expanding the logarithms. So that's going to be a big portion of the test, or the quiz, excuse me. And so since I've already gone through those on your homework, I'm not going to go through those again right now. So hopefully you were paying attention as I went through your homework. The last section on the test, other than what I've already talked about, is graphing. And so you'll probably have, I'd say, 1 graphing problem on there, on this, since I gave you 2 graphing problems on the last quiz. So when you look at this, remember with graphing, what you're talking about is taking something that looks like this, y equals, let's say 2 times, let's go with 1/2 raised to the x minus 4, let's say plus 4 minus 3 power. Remember, when you are looking at something like this, always focus in on just that first little part, just the 2 times 1/2 to the x. That's what you want to make a table of values for. Not because I think you guys are dumb, but because I'm trying to make it easier for you to type in your calculator. Because when you make a table of values for that guy, all you have to do is plug in your -2, -1, 0, 1, and 2, and plug it into that simple 2 times 1/2 to the x power. Because then what's going to happen is I'm going to be able to just find some quick little numbers in my calculator, much like I did those values that we did with the bank accounts, car values, those types of things. I just typed this in, my beginning amount, parentheses, raised to a power. So when I do that, when I raise this to the negative second power, this is going to give me 8. When I raise this to the negative first power, it's going to give me 4. When I raise it to the 0 power, it's going to be 2. Remember, the beginning amount is always going to be right here. When I raise it to the first power, it's going to give me 1. When I raise it to the second power here, it's going to give me 1/2. So then you take those points and you plot those points on this graph, and then you move them. Remember, when you're graphing these guys, they don't have to be all the points on the graph. If I gave you something that's a little too high, 8 is not too bad. I should give you room for something like that. But I think on the previous quiz you had one that was like at 32. Don't worry about trying to graph the point if it goes all the way up to 32. Graph the main ones that still fit on this graph and you'll be fine. So we'll take this guy and we will graph these points. So when we graph our parent function, well, that's an awful line, isn't it? We'll leave it. When we graph this parent function, -2, 8, when we go left 2 and we go up 8 spaces, it would be here. -1, 4 is here. 0, 2 is here. 1, 1 is here. Then 2, 1/2 is here. Remember, this graph has this ramp shape to it. It's a decay function because it was 1/2. And this thing is going to flatten out right here, but it's not going to go below 0 because it has what we call an asymptote. But then what we're going to do is we're going to take it and we are going to move it. Remember, opposite, same. This graph is going to move left 4 spaces because the opposite of this, and down 3 spaces because the same as this. So you take every single one of these points and you move them left 4 and then down 3. 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 And you'll notice you have the same shaped graph, but it's left 4 spaces and down 3. And then when you connect your dots with this guy, you're going to have to take this guy right here and make sure that when you curve out this way, that you flatten it out, because that asymptote is also moved down 3 spaces. And if you do not draw your asymptote on here, you will miss a point. At least 2 if you also mess up your graph and don't draw it down below here. So you've got to draw that asymptote to know that that line doesn't keep going down below there. So that's everything that's going to be on the quiz. Good luck. I hope you guys do well, and you don't have any homework, so I'll see you guys next time in class, and we will be finishing out the chapter. We'll be talking about solving exponential and logarithmic equations. Good luck. Do good.